Hello everyone, welcome to the third episode of the LLM show. I'm your host Shaman Siri. Today I have a special guest, Ryu, who is my good friend, and we are going to go through how to fine tune open source LLM models like Falcon with custom GPUs, like especially considering their enormous amount of parameter size. We all know it's not easy to kind of train them without having large GPUs or large servers. And yeah, let's talk about what's the best way to train this kind of a model. Before going into the episode, let me first introduce my friend Ray. So he has done his undergrad in the University of Auckland in electrical and electronic engineering. Then he's currently working on his PhD. I met him around 2018 when I first moved to New Zealand, and also we have worked on some amazing projects like open sourcing some of our models with Hugging Face Transformers library. So yeah, to you, Ravind.
Okay. You basically said most of the stuff. Um, so I've worked with you since we were doing deep reinforcement learning before, and then we moved on to NLP and other stuff. I am currently working as a senior computer vision and AI engineer at a startup company, and before that, I did some consulting as well. What else do you
Okay.
want?
Yeah, that's pretty much it. So, what do you think of these large language models?
No, it's quite cool the progression from ChatGPT up to right now, like how fast it's progressed, and like ChatGPT being a commercial product that they didn't really release any code or models, to then things like Llama being open sourced, but the model being the weights not being available. But then we've started to get first not models that you couldn't commercialize to now we're getting models that you can that are fully open source and commercialized. So it's been quite a wild ride, and there's a lot of interesting innovations in the space, I guess.
Yeah. So, have you heard of? I think you surely have heard of Falcon models. Actually, I did my previous episode on that. So, basically, Falcon is like the first open source, fully open source LLM model where we have access to, and that means we have the checkpoint, we have the commercial license, and we kind of can use it and build our own industrial applications on top of it.
Actually,
So it's
there was like a Databricks model as well, right? What's the
yes.
difference between this one and
Uh, I think like Databricks
Dolly?
model. I mean, I know like most of people are using it, so it's Dolly. I guess it's more like you do you have access to the checkpoint, or is it hosted in Databricks? I think it is hosted in Databricks, right? You kind of can build, and it's more like
I
it's
don't.
more like they give kind of an API or something. If we even take Dolly, I don't know whether we can kind of load that checkpoint without Databricks servers and all. So,
Yeah,
but
I don't know.
when it comes to Falcon, you literally can download your checkpoint similar to Bert or Roberta or something like that. Yeah, and like today's episode, the main thing I want to actually discuss is about how we can fine tune, because when it comes to industry, we might always need to kind of use these models for our custom applications, right? So then fine tuning can play a huge part, because um, right now the research has already shown that kind of rather than using the model as is, uh, if you can kind of fine tune your data uh, with I mean for your custom task, these models can yield better results. So, but then the problem is how we can fine tune them. Large language models are kind of models that have more than 10 billion parameters. I mean, that's pretty much what they say. Like
There
any
are 7
model,
billion classes now.
yeah. Like what they say is any model that has more than 10 billion parameters, it's hard to fine tune on commercial GPUs unless or otherwise you have your own server. So now this is a big problem, right? Like, because not every company can kind of afford to have their own GPU setups or GPU servers, and Also, right now we all know in the industry, the GPU costs, like it's not easy, and it's not also practical. Then like then the thing is, like, there's this new type of techniques, like people are working on that. So we call them parameter efficient fine tuning. So basically, they are working on how we can take a large language model checkpoint and somehow squash that checkpoint into a commercial grade GPU and train it in a way for a custom task or with your enterprise data, and get better results. So that's pretty much what parameter efficient fine tuning is. And I first read about parameter efficient fine tuning around 2021. So I think some researchers from Cambridge and Google, they were like doing a lot on this concept called adapters, kind of adding few layers to the model and keeping the model kind of frozen. But
How is that different from like good old days computer, like convolutional neural nets where
yes,
you
that's
froze
that's a very
the?
that's a very good question. Like people always ask, like, is it similar to kind of adding a single layer on a first frozen model? We used to do this, like, pretty much with ImageNet models. So what I think is, because after that, research found, if we fine tune all the parameters, we get better results. That's what happened with
Mhm.
self-supervised learning model. Like, pretty much that's what we did, right? In our papers, we used to fine tune BERT, not even like thinking twice, because it is giving better results rather than adding another layer. But only difference in adapters and these kind of parameter efficient fine tuning is they kind of try to inject layers in between. It's more like, it's more theoretical, I'd say. But still, yes, still keeping things frozen would work. But they have shown, like, if we keep it frozen, this is the accuracy, and if we use this kind of injection, this is the accuracy. So yeah, this is, so I think, like, well, this is a very good thing for researchers, right? Like, what do you think? I mean, having these kind of methods to use LLM.
Yeah, adapters. Yeah, because I mean stuff like LoRa we'll probably be talking about in this episode is
Yes,
quite.
yes. The question is, since you're also in the industry, do you think, like, we will uh, we will be seeing a lot of innovations in this research direction, and how effective those innovations will be for industrial applications?
I guess it's definitely gonna have an impact because it would have been difficult for like smaller companies to adapt their model. Like if they have large language models and they want to use it for a specific use case or a specific application, without like these types of things, it would be quite difficult, and they'll probably be playing around with much smaller models than if these innovations are not there, like LoRa and QLoRa and whatever
Yeah,
else.
yeah,
So
yeah.
it's
That's,
definitely
that's
going to have an impact.
yeah. So
Um,
what do you think? So my last question before jumping into the today's topic, like, what do you think of these kind of methods versus using APIs? Like, how can I say industrial grade LLM? Yeah, like
like
OpenAI.
yeah,
Like, they will also give the kind of ability to do this stuff, right? Just dump your own data. We will do it.
yeah, I think a lot of industries and a lot of big companies do care about where their data is going, and they don't like the fact that it's going to OpenAI, or even though they say in their agreement they won't use it for training, still large companies are quite cognizant of the fact that the data is going outside their control, so they don't want their customer data or their proprietary information or secrets getting out. So, like, even though that could be an option for some people, for some customers or for some industries, say health records or things like that, it's definitely important to for companies to be able to do it all in-house instead of like using APIs and stuff. The
Yeah,
APIs might
yeah,
still be better, but still um, doesn't work for some people.
yeah. That's a pretty good point. Because the other thing is, we need to ask from ourselves whether we need to depend on an API, which is kind of quite scary, because I think I've been talking about this before as well. So once when the first deep learning first came and all, I started to see a lot of APIs like IBM Watson,
Mm,
Google also had those kind of stuff like for to do this quick computer vision training and all. But still people started to build their own tech stack, right?
yeah, it's also like those platforms usually are quite. It takes them quite a while to adapt the newest technology as well.
Yeah.
Like if the newest models might give better performance, but then you have to wait for Google or whoever the provider is to integrate those technologies. But if you're in-house, you can probably do it faster and have a
Yeah.
competitive advantage as well.
Yeah. So yeah, let's jump into the kind of today's main talk, like how to train Falcon 40 billion or 7 billion model. And I guess like within next few months, we will see a huge boom in this area. This is really good for especially machine learning engineers, like because I remember some people were talking about maybe the future is all about prompt engineering,
Yeah,
where
yeah,
there will be a person sitting in front of the computer try will try different how can I say different text inputs, like different patterns to get the best results for me, which is again we are going back to the start, it's not AI. Then again person will try to figure it out, but now it is this is a fact now.
mm,
Almost all this new research has shown like actually fine tuning methods can give way better results rather than just using prompt engineering. So I
yeah.
guess
Prompt
for
engineer was only a very short-lived, sexy job.
yeah, so let's jump into this. So
Yeah,
let's start with the blog. They have a blog like the Falcon has landed, which kind of explains a bit about Falcon model. And I'm not going to explain about Falcon model, it's just a transformer, and I also like explained it in the previous video, but we'll try to kind of go through what are these techniques behind fine tuning. Okay, so I'm gonna like share my screen start. So basically the topic, so this is like in the in I mean you can find this blog. So basically the Falcon
you
has
might.
landed in the Hugging Face ecosystem. So during the introduction they say why this is the first ever fully open source model, why it is important. Pretty much they say like okay, there are two models, one is 40 billion, the other one is like 7 billion model. That's pretty much it. And yeah, so in the table of content, but I kind of have highlighted important things that I thought of, so this is really great. Remember I was talking with you about this thing, like how much memory would it take
Mm,
for the inference. So I think this is the inference. So they
yeah.
say like Falcon 40 billion requires 90 gig of GPU memory. So
Mm-hmm.
and but Falcon 7 billion can run with 15 gig. So I think this is like for the inference. So this is a good
It
thing.
says making inference and fine tuning. So are they referencing LoRa? I guess maybe.
Uh, Here,
Okay.
no. I The problem is like you would at least need a 90 gig GPU to kind of host this. That's what I
Yeah, yeah,
realized.
yeah,
And so this is big, right? This is really
yeah,
big, and this is not
yeah.
easy. That's why we still need to use APIs nowadays. But I would say this blog post has changed everything. I mean, the model is pretty much like a normal transformer. So the idea is like we all know, like in when it comes to transform architecture, from the attention is all you need paper, there are like 16 heads, right? So for each head you have a query, key and value,
Mm,
right?
yeah.
So these three vectors. But when it comes to multi-query attention, what happens is like key value vectors being shared in between these like heads. That's pretty much it. So what they say here is trick doesn't significantly influence pre-training, but it greatly improves the scalability of inference. So what they're saying is, yeah, we can make the inference faster by using this multi-query attention. This blog they have mentioned like how to do the inference and all. This is pretty much how they do any other Hugging Face model. You just load the model and load the tokenizer and use a pipeline or something, then generate text. But here I really like their information. So what they say is running 40 billion model is challenging because of its size. It doesn't fit in a single A100 GPU with 80 gig. So
Hmm.
this is a lot, right? And then loading in 8-bit mode. So we'll talk about this in a minute. Like so, how 8-bit is like. You remember about this mixed precision training and all, right?
Yeah, yeah, like training or yeah,
Yeah,
yeah.
yeah, training. Remember
Understood.
there was an NVIDIA paper like we are
And
pretty
like
much
Google,
using it like yeah,
well, somebody
like
has a special format like bfloat
ah
16.
yeah, it's from Google. It's from Google actually.
Yeah.
So um yeah, so loading in 8-bit mode is like pretty much we all know like when it comes to the computer architecture, we there's a there's a trade-off between the precision and the size. So usually these models are trained with F32 or FP32 or like uh, this new thing. I think if it's called Brain 16 or something, FP Brain 16. It's from Google.
Bfloat 16.
Yeah, B float. Yeah, it's Brain, right? Brain float 60. So it's from Google Brain, I guess. So the what they say is you can actually load this with 8-bit mode. Still, you would need 45 gigabytes of RAM, which fits in an A600. So this is like 48 GB A600 A6000, but not in 40 gigabyte version of A100. So anyway, the idea is like what they're saying is if we just try to use this checkpoint and try to do some stuff, it's hard. I want to give an advice for new researchers, like special PhD students. When you are trying to think of a research topic in this area, make sure you can fine tune these models, right? I mean, otherwise they would run into a huge problem, because you can start this amazing research and all, then you suddenly find, oh my god, I don't have enough GPU memory or something.
Have a lot of money or your university need to have a lot of GPUs.
We had 10 GPUs back then. I
So you'll
mean,
have to
just our
share it.
department. I think
Yeah,
still it is there. And it's 32 gig V100s, right?
I think so.
Yeah. But then again, you can see this model needs 80 gig of GPU. So the idea is like if we use like maybe like several GPUs, we need to go with something like model parallelism or something, which could affect the speed of inference and training by a lot, right? Because those methods can kind of add a lot of deadlocks, I would say.
Yeah.
Yeah.
Either way,
So
it'll cost a lot of money either way.
yeah. So the idea is they say like, listen, this way it doesn't work. So, but we have a remedy for this, and then they say like, there's also a possibility to use 4-bit loading. I think this is now Hugging Face library is pretty much official with bits and bytes. Within one command, you can convert any pre-trained model into 8-bit precision or 4-bit precision. So which is awesome. So basically, it says the bits and bytes is a lightweight wrapper around CUDA custom functions. In particular, 8-bit optimizers, matrix multiplication, and quantization function. Wow, it is really good, man. It's from Tim Detmers. I hope I read his name correctly, but kudos to Tim. We'll go to the fine tuning, right? Okay. So PEFT,
No, I don't
it's
know that.
like a new library like Hugging Face datasets, Hugging Face transformers, Hugging Face tokenizers, and we have Hugging Face PEFT, right? So
Okay, yeah,
it's for parameter efficient fine tuning. We will go through that in a different episode for sure. But yeah, it's pretty much it's a legit library. I kind of checked it, and they have combined it with even their trainers, the trainer class,
Mhm.
so
So
which
you
is
can use
pretty
PEFT
easy.
to implement QLoRa.
Yes, exactly. The good thing is it is already been implemented. We don't have to
Mhm.
do anything. Yeah, I mean,
Also,
yeah,
we don't
I
have to worry about any of the memory management
no,
stuff.
no, not at all. Yeah, that's a good point you mentioned. So if you want to run these kind of models in your own company, you actually don't need to know any theory. I mean, you can just there are nice notebooks and all. You can just you can just blindly execute the code. But I'm highly against it because I feel like this field will get super hierarchical, similar to all this deep neural network research. So it is better to kind of understand the basics. Once you understand the basic, it's really easy to kind of learn new concepts in this field, right? So what they're saying is any model with the size of more than 10 billion parameters is not easy to like kind of fine tune or train. It's computationally challenging. And what they say is they kind of with their new with their these new methods of like kind of parameter efficient methods, they kind of can even run Falcon 16 billion model on
7 billion.
Google Colab, which is amazing, right? Like
Yeah.
we get the ability to kind of test this stuff, and also we get the ability to kind of build build stuff on top of this, which is pretty awesome for me. They use PEFT library, and then with the PEFT library you can use recently published QLoRa approach to fine tune adapters that are placed on top of frozen 4-bit model. So yeah, this is now pretty cool. um, I kind of really like this QLoRa paper, and I enjoyed reading it a lot. So we'll go through it. But Ravindu, like generally the idea here is how this workflow works is with QLoRa.
Yeah.
So LoRa is like low rank adapters, right?
Yeah.
So that means you have a huge LLM, right? And then you keep all these your LLM parameters frozen, right?
Yeah. Yeah.
And then what you do is you add these you kind of inject these new layers which are like quite small, and you only fine tune these layers. So basically you don't need to store the gradients for those frozen parameters. You just only need to store the gradients for your LoRa layers. And we what they have shown is we can still get like the optimal results with
Yeah.
by only fine tuning these newly injected parameters. So which is pretty cool, so and then that is LoRa. What QLoRa says is not about okay, we can still inject parameters, but
Yeah.
still we need to keep this big LLM model. We need to keep this big LLM model to kind of generate embeddings or generate like in between, I would say, inputs or outputs, right? Because
Hmm.
these are like LoRa will get injected to different layers, like in between attention or in between fully connected layers. So still you need to compute outputs from these LLM models.
Yeah.
And LLM model itself is quite large. If we
Yeah.
use like commonly right now, the state of the art is, I guess, B float 16. So what QLoRa says is we can actually downsize this large LLM. We can actually do this entire fine tuning process on a single GPU, which is pretty good.
Before
So
with just LoRa, you had to do the forward pass and the inference basically on the CPU, and then just a fine tune a bit on the GPU. Or
oh, that's a yeah. I mean, I would say that's a way, but I kind of checked. I would say before LoRa, what they did was they were just quantizing the model,
Mhm.
maybe converting it to 4-bit. and
Yeah.
just fine tuning on LoRa, fine tuning
Yeah.
with LoRa layers. But QLoRa kind of has shown a new method to quantize this model,
Hmm.
and without losing its performance. Because
I'm surprised it only needs 65 megs.
yeah, exactly, me too. So this blog is really good. It has all these technical terms, so if someone wants to go into them, you can always like follow. They have all the links and all. So do you get the idea? Like they fine tune Falcon models for custom tasks. It's with two main things: using LoRa and using this quantization method, and in combination we call it QLoRa, right? It is pretty much like the state of the art.
Yeah.